Okay, in this video we're going to talk about comprehensions. We're going to start with list comprehensions, but there are a few other types of comprehensions to talk about. A comprehension is sort of a way to quickly make an iterable or a list using a special syntax in Python. Okay, and it allows you to sort of map one value to one list to a set of values. It's kind of like the map function, but it's sort of a different syntax and it has some extra features. Okay, so if you haven't learned about the map function, I just posted a video about map and range and iterables. You can take a look at that. So let's start with a simple map. So I'm going to have this map object m and call the global map function. And this takes two parameters, a function and then an iterable of some kind, right? So we're going to use a lambda function. So lambda x, this function takes in the parameter x, and whatever comes after the colon is the return value. And so we're going to map this, we'll say x divided by 2, and we're going to say we're going to go over range 1 to 9. All right, so the starting point of 1, we'll go to 9. That gives us, it'll stop at 8 because we never include that last value. So here's our map object, and we can tprint that. So tprint is a little function I've been using recently. It just prints out the type of an item and then the item itself. So we're going to tprint that to see what that is, and then we're going to tprint the list version of that map object. Let's see, we want to call comprehensions. Okay, so first we have a map object, and then we get this list object. All right, now look what happens when we call list over this again. We get an empty list. Okay, that's important because map is an iterable. When we get this iterable, we can iterate over it only one time. And so the list function, what it does is it iterates over that object to completion. And then when we call list again, that iterator is already at the end of the list, and so it gets the stop iteration event raised again. And so, but it hasn't added anything to the list this time, right? So we get two different lists. The first one, the iterator actually started at the beginning and went all the way to the end. The second time through, it was already at the end, and so we weren't able to produce any values for our lists. Okay, so this is important. The iterators can be exhausted, right? So when they get to the end of the list, you can say that they are exhausted. All right, so we can also say something like this. So we don't have to always just store our map variable here. If I know I want a list, I can say something like this, list map, and then lambda x divided by 2, and pass in my iterable, and that's going to be the same range function. And we can tprint our list value here. Okay, so we get this nice thing here. All right, so what is a list comprehension? So this is sort of our starting point. A list comprehension is sort of going to mimic this behavior, but it's a little nicer syntax. Map, oh, this is list comprehension. All right, so in a list comprehension, I can kind of do this same thing, right? So notice what we're doing. We're using two functions. We've got this lambda function in here, and we still have our range. So we're going to still use that range function, but I know I'm going to have a list, and so if it's going to end up as a list, I can just use this square bracket notation, and I'm going to specify on the right hand side what do I want to end up with. So I want to end up with x over 2. Where does x come from? Then we have our for statement. So for x in our iterable range 1 to 9. Okay, so that's what this x is. It's the x from this for loop. So like imagine you're just writing a for loop up here for x in range 1 to 9. you know, x over 2, you could append this to a list. You could have some list up here, li, and you could say li dot append, right? Something like this. But this is also wordy, right? So we can do this all in one line here, right? It's effectively the same as this, and it's effectively the same as this, right? So we can tprint both of these, tprint li, right? But this is the actual comprehension. This is a list comprehension. And we'll tprint that as well. Okay, so both ways, this was the for loop. It's just more verbose to do this, lots of lines of code, and this is a really quick one-liner. It's a little bit easier to read than something like this. Look at all the parentheses, the lambda, map, and list. It's a little bit much, right? So this is just a nice, cleaner syntax for doing the same thing. So that's the basic of a list comprehension. But as it turns out, there's additional things you can do with the list comprehension, any of the comprehensions. So when I say list comprehensions, I'm just talking about comprehensions that end up in a list, right? So things that end up in a list. There are also dictionary comprehensions, tuple comprehensions, and comprehensions that just make generator objects. All right, so there is a way to filter a comprehension. Okay, so let's look at that. We're going to make a list comprehension. We want x divided by 2 for x in range 1 to 9. Right? And we want to filter out the even numbers, or we could filter out the evens or the odds, right? So we could say if x mod 0, or I'm sorry, mod 2 equals 0, then it gets added to our list. So this is a filter, right? So it only gets added to the resulting list if this is true. Okay, so this is only true for even numbers, right? If you divide by 2, the modulus is the remainder. So if there's a 0 remainder, that means it's an even number after you divide by 2, right? So this should produce the list range of numbers 1 to 9, so 1 through 8, except it's only going to be the even numbers. So we can tprint that. li, and we can run the example. If, let's see. Oh, right. So we have this x over 2, right? And so this is 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. Right? So we're doing a lot of things here, and it's all in sort of one line. Right? I want x over 2 for every x in this series if that x is even. Right? So this is sort of, the idea here is sort of writing the code the way you might say it, right? So Python's big on that. That's why it uses English language operators like in, and we have and or is actually the words and or, Boolean operators, that sort of thing. So the Python creators are big on this. So we have this idea where we can just say something, and that's sort of how the code is written. So I want a list of values x over 2 for each x in this collection if that x is blank, right? In this case, if x is even. And so that's what we end up with, this situation here. So notice we took out half of them. All right, all of the ones that were odd would end in a 0.5. So 1 divided by 2 is a 0.5. Right, 3 divided by 2 is 1.5. So we filtered, and then we applied the mapping. Okay, so that's the idea. You have your for loop syntax in the middle, you have a filtration on the right, and then you have your mapping value on the left. And that's it. That's all there really is to a comprehension. Now, there is one additional thing that can make comprehensions a little bit harder to read, and that's the ternary operator. All right, so we'll take a look at that. Hopefully you guys have seen this before. If not, now you should get a chance to see it. So the ternary operator sort of gives you an option of two values for a variable, right? So let's define a simple function, and we'll call this ternary. And we have some parameter s. This is a named parameter, so this is a keyword argument, and we're going to start the value out at none. And what we want to do is we want to say s is going to equal s if s does not equal none. Else, or otherwise, we're going to say s is banana. All right, so what is this saying? If we do pass in a value for s, okay, so say this is apple. So s, we're going to set s equal to whatever s already is. So if it's apple, it's going to stay apple as long as s does not equal none. But if s was none, then we're going to store banana in there. Okay, this is a ternary operation. So this is what you return if this statement is true. Otherwise, you return this. Okay, so s is going to be what it already is as long as what it is isn't none. And if it is none, then it's going to be banana. And we'll just print out s. So let's call ternary in a couple of different ways. Ternary with a variable apple, and then we'll call ternary with no value. Okay, so we get apple and banana. Right? So apple goes in here. So s becomes the value apple. S equals apple if apple does not equal none. Well, apple does not equal none, so this is what gets returned, apple. The next time through, we pass in no data. Since this is a keyword argument, it gives us a way to set a default value, and we set that default value to none. And so we say s is going to equal whatever s is, which is none, if none does not equal none. Well, this is false. None does equal none, and so we have to go to this else statement and return banana. And so that's what gets printed the second time. So this is a ternary statement. Lots of programming languages have the idea, the concept of a ternary statement. Python's is a little bit unusual compared to other programming languages, and because it has this syntax, it's supposed to be kind of readable, just like the comprehension syntax. So it's kind of like you would say it. Give me the value s if s isn't none, otherwise give me banana, right? So it's the same idea. Now the problem with this is here in your mapping area of your comprehension, sometimes you'll see someone use a ternary, and that can get a little bit hard to read. But let's take a look at an example of that, of a ternary in a comprehension, just so you can kind of see what it looks like, and you won't be scared off if you see something like this. So print ternary in comprehensions. All right, so for this, what do we want to do here? Let's simulate some scores. I'm going to make a list comprehension. Let's import the random library. I'm going to generate some random values here in the list comprehension, and you can do this however you want. I kind of like to start with my my for loop. So for, what do I want? I want probably a few scores here, so 10 scores maybe. So for I in range 10, this is how you would normally start out with comprehensions, just because you're sort of used to creating the for loop first, right? But as you get better, if you know what you're gonna do, you can actually just start typing out the comprehension as you go. So it might be a good strategy to just start with this for loop, and then the mapping is what goes on the left hand side of that. It's the beginning part. So what do I want here? I want a random.uniform, and I'm going to get a score between 0 and 100. So the random.uniform gives me a uniform distribution of likelihood for a random number between 0 and 100. So that's sort of like a student score on something, right? Or any kind of scored quiz that goes from 0 to 100%. All right, so we can look at this. This is a quick way to make a list of random values. We've got 10 of them, right? So let's take a look at that. We can print the scores. All right, so these are good. 13, 98, 1. These all look like they're between 0 and 100, so that's good. A lot of decimals there. It's kind of noisy. Let's use the round function around that, and we're going to round to 2 decimal places. There we go. That looks a little bit better. It might be more realistic scoring. Run it a few times. There we go. So let's take a look at the ternary with this comprehension. All right, so we have this comprehension. It's a list, scores that we've created. Now we're going to create a list called PassFail. And this is going to be a list. We're going to use a comprehension syntax for score in scores. So that's sort of the iteration aspect. What do we want to map to? We want to map past if the score is greater than 60, else failed. All right, and then we'll print scores. I'm sorry, print PassFail. Okay, so scores was generating a random number, and then for each one of those scores, we're going to check to see if that score is greater than 60. If it is, this is what gets returned to our list. Otherwise, this is what gets returned to our list. Okay, so the only things in this list are going to be either this value or that value. And that's what a ternary operator does. If this condition is true, return this. If this condition is false, return that. Okay, so we see 59, failed. Let's round to a few more digits so these line up a little bit better. So we're going to round to 4 digits. There we go. So 76 is passed, 78 is passed, 68 passed, failed, passed, failed. Right? So these all appear to line up pretty well. Maybe we'll do 5. And we'll line up a little bit better. A bit of a glitchy computer today. In just a second. There it goes. Get the screen back. There we go. Alright, so we save that and we run this again. Alright, we'll stick with 5. Alright, that's just to make the lists kind of line up a little bit so we can see 54 is failed, 81 pass, right? So these just kind of line up. That's fine. So there's another thing you can do. Let me grab my other file here, my little cheat sheet. There's another thing you can do where you can, this section to the left of your iteration is sort of a mapping, and you can do whatever you want here. You see how we called a uniform function and then we put that inside of round. You can do any number of things here, and you can even call other functions. So one of the things we could do is we could define a simple function called grade, and we pass in some value x, and we can say, or we'll call this a score. These are grading scores. And we can say if score is greater than or equal to 90, then we're going to return, an A, and we're going to print out this list, and we want it to kind of match these, so we're going to add some spaces right? And then duplicate this line a few times, and we'll say if score is greater than or equal to 80, 70, or 60. And then we have A, B, C, and D. And then otherwise we will just return F. Okay, so this is going to get some score value. If the score is greater than 90, we return A, B, C, D, and F. And what we can do is make a comprehension here, grades, and we can say take the grade of a particular score for each score in the list of scores. Right? So something like this, and then we'll just print out the grades. Again, the spacing here is just so they line up when we print this out. Okay, so 99 passed A, 76 passed C, 69 passed D, right? And then we get to a failed, 54 failed F, right? So these are comprehensions. This is the idea, and it's basically just a nicer syntax to iterate through a list of items, because it turns out as you get further and further in your programming career, this is something you do all the time. So it's really nice to have this handy syntax. All right, let's see if we can do something with translation with filtration. All right, so remember, the filtration is the stuff that occurs on the right-hand side. So what we can filter out, whatever sequence we're iterating through, we can filter out items using that if syntax on the right-hand side. So that's we're gonna do that. That's what we mean by filtration. So we'll do something like, let's print our little section. This is translation with filtration. All right, and so let's make a little function that's going to produce a random value, and it's going to produce a none value sometimes, right? So let's say we have some students, and sometimes in our scores list that we made up here, instead of it always being a value, sometimes a student's going to have a none value because they didn't take it. All right, so we're going to make a little function that does that for us. We're going to generate either a random or none value, and then we're going to have some none check, and we're going to set that equal to random.random. So this produces a number between 0.0 and 1.0, and 0.0 is inclusive and 1.0 is exclusive. All right, so this is going to give us a number between there, and what this allows me to do is I can say, you know, if 0.10 is greater than some random number, my none check. So if 0.10 is greater than the none check, that means that none check has to be below 0.10. So 10% of the time this is going to be true. So I'm basically making a condition that's going to be true 10% of the time. And if so, then I want to return the value of none. Otherwise, I'm going to return random.uniform. We're going to go from 0 to 100. We're going to round to, what did we want to round to? Just 2. Okay, and then we can say our scores. I'm going to do a list comprehension. We're going to call random or none. That's going to be the value we return for I in range, and we can produce 20 values. Okay, so that's our first list comprehension. Let's print out scores. Okay, so, and we get some none values in there. It should be about 10% of the time, so it's not unusual. We would only see 1 in 20. There's 2. So on average it should be 2, but occasionally, like, we got a lot of nuns that time, right? So about 10% of the time we get this none value back. All right. Now what we want to do is make another comprehension to basically eliminate those none values, right? So we can say scores equals score for score in scores if score. Okay, this is just, all this is doing is filtering out the none values. Okay, so for score in score is going through this list of values, and sometimes there's a none, and so if it's a none value, this is false. So if of none is the same as if false. So if it's false or if it's none, we don't produce the result in the resultant scores list, right? But if it's not none, we do. And then we can say scores dot sort something like that, and we can print them out. Sort of a neat trick if you want to print out the items in a list one at a time. Instead of making a for loop, you can do something like this. You can use the expansion syntax. So this is going to expand out each of the individual items in our list as arguments to this function, and then I can say the separator between the things that I print out, so between the arguments, is normally just one single space with the print function, but if I do this, then the separator between printing these things out is the new line character. Alright, so then I can print this out, and this gives me a list of all of the scores, right? And if I want them in reverse order, I can just say reverse true. Right, gives me nice little scoring order. All right, let's look at generators with comprehensions. So comprehensions as generators. Okay, so let's say we have some variable called ABC and ABCDEFG. All right, this is iterable, and we can make a generator, and it's a generator comprehension. So the only difference between a list comprehension and a generator comprehension is a list comprehension uses the square bracket notation, and a generator uses the parentheses notation. But everything else is exactly the same. And what is returned instead of a list is a generator, which is an iterable. All right, so let's say we wanted to do something like this, and we have a format string, and we want to print out X, Y, and Z for X in I skipped a line here. Let's go back. We got our generator function. There it is. What we want to do is we're going to take this and we're going to generate values one character at a time, but they're going to be shifted in ASCII value by like 4 or by like 2. We could shift everything by one value, so an A would become a B would become a C, something like that. So we're going to make a generator for that. So we'll start with for X in ABC, our function. So X is going to be a character in that list, and what we want to do is convert that value to the ordinal, which is going to give us the ASCII number, right? So we're going to convert that to the ASCII number. If you're not familiar with the ASCII numbers, every character in the English language has an ASCII value associated with it. The lowercase letter a is 97, uppercase letter a is 65, and so since everything's stored as a number on the computer, right, it makes sense that the characters would be stored as numbers too. So the ord gives us, if we pass in an individual string character, it will give us the ASCII value, right, or the ordinal number, right? So this, if this is A, it should give me a 97. A B would be 98, etc. So what I want to do is take that ordinal number and I want to shift it by some amount. So let's just shift it by 1, and then I want to convert it back into a character. CHR like that. So I have this generator. All right, and then what I can do is tprint my generator, so we see what we have. It is a generator, right? And that makes it the generator is the parentheses using is that instead of the list comprehension syntax with the square brackets. Now I can do several things here. I could produce a string, so let's tprint the string using the generator. Actually, that's just, I think, just going to give me the string representation of that generator. What I really want to do is I could make this a list and then do .join. Right, so that would give me a string. Wonder if join takes an iterable. I've never tried that before. Let's try. Ah, nice, it does. So we can use join, and it just takes the iterable directly. All right, so this is going to start with, you know, A, B, C, D, E, F, G. You can tprint that. A, B, C. So that's what we start with, and we see each of the values shifts over by 1. And we got a generator this time instead of a list. If you want a tuple comprehension, you have to make a generator first and then convert it into a tuple using the tuple function. So a tuple is just a list that is not mutable, right? Lists are mutable, you can mutate them. Tuples, you cannot change their values, just like strings. I can't change the value of a character in a string. All right, so we have this tuple, and we want to pass in our generator. So we'll look at that. Our generator was exhausted, right? So every time you make one of these comprehensions, it just makes a generator. It doesn't make, it doesn't reset once you iterate through it. So we have to do this again if we want a tuple. Right, and technically we might do something like this. If we know we're going to use it right away, we don't need this G variable. Right, so I'm going to make a tuple from it right away. Okay, and we have this tuple now, and we can't change any of those values. All right, so that's generators. You can do nested comprehensions. All right, so let's take a look at that. All right, so let's look at, we're going to do a list comprehension. Well, now we're going to say, I got a little ahead of myself before, we're going to say X, Y, and Z. For X in ABC, for Y in IJK, and for X, well, this should be X, for X in ABC, for Y in IJK, and for Z in XYZ. Okay, so what this is going to do is this for loop is like the outer loop, and each one of these is like nested underneath the one before it. Okay, so this is a for loop for X in ABC. So the first time through that loop, X is going to be A. So this is going to be A while these two other loops execute. So this will be A for the whole time while we go through this loop. The first time through this loop, this will be I. So we should say AI, and then this loop will go through and we'll see X, Y, and Z. So it should be AIX, AIY, AIZ, and then Y should increment to the next letter. All right, so it's just like nested for loops. And you should see the result. This should be how many different ways we can combine ABC, IJK, and XYZ, right? So there's 3 options for the first one, 3 options for the second one, and 3 options for the third one. So that should be 3 times 3 times 3. And we can print out our list. And we'll use this expansion syntax again. Separator equals the new line character. And we'll also print out the length of our list. Which is not defined. Oops. Okay, so there are 27 of them. AIX, AIY, AIZ, right? That's all the different ways you can arrange if the first character can be ABC, the second character can be that, the second character can be that. We could also just do ABC for all of them, right? And you still have 3 options, right? So you could have all A's, 2 A's and a B, 2 A's and a C, something like that. And there's 27 possibilities. All right, and then the last thing we want to do are dictionary comprehensions that are the most complicated, but they're not that hard. Print dictionary comprehensions. And what we want to do here is let's have a dictionary. I'm going to just copy and paste this because it's a little bit much to type. If you want to type this out, just pause the video. So we have this grades dictionary. And so we have Alice, Bob, Candace, and Frank. So Alice starts with an A, so she obviously makes A's on all of her assignments. That's how it works. And she's got an email address here. So we have email, alice@example.com, and then we have a quiz 1 and a quiz 2 score. Bob, he gets B's on everything, bob@example.com, Candace, etc. And then Frank doesn't show up for his quizzes. All right. And so what we want to do is we want to make a dictionary comprehension. So one of the things we want to do is we want to have something to iterate over. So if I have a dictionary, like grades, if I say grades.keys, that's going to give me an iterable that will iterate over each one of the keys in my dictionary. All right, let's tprint that. Keys. Tprint keys. Grades. Yes, grades.keys. Grades is our dictionary. So dictionary keys. This is an iterable, and it's effectively this list, but it's not this list. It's just an iterable. All right. So if I want to make it a list, I can do that. By doing that. Right. So I guess we'll do that here, and we'll say list. Keys. Okay, and now it's an actual list. See, it says list there, and this is the actual list. If we duplicate that line, this is one of those interesting iterables. This is more like the range object, where we can repeatedly iterate over it. Okay, so we can get a new iterable each time. All right, so you have this keys object. That's important because when we're making these comprehensions, we have to iterate over something. We have a for statement inside, right? So I want a dictionary, and I'm going to start with that for statement. I'm going to say for name in grades.keys. Okay, and I'm saying I'm calling this thing a name because that is what this is. So this is going to give me either Alice, Bob, Candace, or Frank in a list form, right? For that name, what I want to do is I want to make another dictionary, but this dictionary is going to be, the key values are going to be the email addresses and then the value is just going to be quiz 1. Right? So whatever score they got on quiz 1. Right? And let's go ahead and grade that score as well. So I'm going to call the grade function. So that we'll get a letter grade for each one of these. All right. Now, if I'm going to call the grade function, that means I need to filter out all the ones that are none. Right? So I can say if grades name quiz 1. So this is going to say if that value is there. So if we do not have a none value, then I'm going to put in here the key I want is grades name. So that's the student. The key I want to use is email. And then colon, the value I want to use is grades name and quiz 1, right? But that quiz 1 score I actually want to grade that with my grade function that I made above. Okay, now you see this is getting kind of long. Let's run this with tprint, and then we'll circle back and see how we can make this a little bit more readable. There's no attribute keys. Grades.keys. I keep doing that. Grades is the name of the dictionary. Okay, so we have a dictionary with the email as the key and their letter grade as the value. Email is the key, letter grade, value. Email is key, and notice Frank was left off because of the filtration. Now when I look at this, I think that this is just a really long, ugly line of code, so we can kind of clean this up a little bit. It would be nice if we could do something like this. That's our result that we want. That is our iteration, and then that is our filtration. Right? If we could do something like that, that would be nice. And it turns out you can. Right? So you can just make this multi-line syntax. This first part is the key, colon, and then the value you want. And then what are you iterating over? And then what's your filtration? And there you go. So this is a lot cleaner, but this gives you an idea of what's in this dictionary. The alternative would be to make a for loop and then add items to the dictionary. But this is much more clear. You're definitely creating a dictionary here. What kind of dictionary? You can look into the details there. All right, so that's sort of the gist of comprehensions. So when you see this scary syntax from now on, hopefully you know how to use it. Play around with it. The more you use it, the easier it gets. So try to work on the examples I gave here. Type them out, and I'll pause here on this dictionary if you want to see it one more time. And you can pause the video and type all this out if you want. But definitely go through these if you've never used comprehensions before or generators. Once you get used to them, you'll find that you'll use them a whole lot because they're very convenient. All right, that's all we have for this video. Thanks for watching.